Today's lesson is on solving multi-stepped equations, and actually this should also say and inequalities. Not my most professional video here, but it'll do the trick. With distributing. So you'll be distributing before solving. So the only additional step to what you've been doing is that you're going to distribute before you solve. So in previous lessons, in the last unit, you learned how to distribute to simplify algebraic expressions, and earlier in this unit you have been solving equations, so it's kind of like a combination of the two units. So as always, your goal has been to isolate the variable. So the only thing that only added step here is that you're going to distribute. Then you're going to combine like terms, remembering to make sure you get your terms with variables on one side of the equation, your constants on the other side, and then you'll just continue to solve like you have been doing over the past few lessons. Some of these will be inequalities and some will be equations, and you know that you solve them the exact same way. It's just that your answer means something slightly different. Okay, so here's the first one. So this is 3 times the quantity d plus 2 equals 12. So first we're going to distribute the 3. So 3 times d gives us 3d, plus 3 times 2 gives us 6, and that equals 12. So you can see this looks just like a two-step equation. So the first thing we're going to do is subtract 6 from both sides of the equation, because we want to undo any addition and subtraction before we undo the multiplication and division. So that leaves us with 3d equals 6. Then we're going to divide both sides by 3. And we're left with d equals 2. So you always want to make sure this works out. You want to check it, substitute your 2 back in, and 2 plus 2 is 4, and then 4 times 3 is 12. It all works out. We're good to go. So that's one of the simpler ones. They get a little more complicated. Let's try one that's an inequality here. So here we have an inequality with distributing, and this is 4 times the quantity b minus 3 is less than or equal to 72. So we're going to distribute the 4. 4 times b is 4b, minus 4 times 3 is 12. So 4b minus 12 is less than or equal to 72. So again, solve this like you have been. We're going to undo the addition and subtract any addition or subtraction first. So we need to undo minus 12 by adding 12 to both sides. And we end up with 4b is less than or equal to 84. Now we haven't isolated our variable yet. We still have a times 4. So 4 times b, we're going to only do the times 4 by dividing by 4. Divide both sides of our equation by 4. And we get b is less than or equal to 21. So what this solution means is that any value that is less than or equal to 21 will make this inequality true. So 21 is less than or equal to 21, so 21 would make this inequality true, or 20, or 19, or 18, or so on. So when we have an inequality, we often graph our solution on a number line. So we're going to plop, sorry about that. Let me figure out how to do that. There we go. So we're going to drop, get my pen back here. Okay, now we're back in business. So we're going to plop 21 down on that number line. Change colors here so we can spot it. And this is a less than or equal to, so we need to color in our circle to show that 21 is included, and all the numbers less than or equal to 21. So anything along that arrow continuing forever in the less than 21 direction to the left, anything along that arrow continuing infinitely in that direction would be a solution to this inequality. So I'm going to pick something nice and easy along that line. A 0 would fall in that set and substitute in here. So 0 minus 3 is negative 3. Negative 3 times 4 is negative 12. And yes, negative 12 is less than or equal to 72. It works out. I probably did things correctly. I might pick 21 also, because I know 21 should get me something equal to. So 21 minus 3 is 18, and 18 times 4 is 72, and 72 is less than or equal to 72. It's equal to, and that works. So I'm good to go. I can move on. I checked 2 solutions in that set. They both work. I probably did things correctly. Okay, so here's one that's a little more complicated because I have to distribute twice. So again, first step, distribute. So 4 times x is 4x plus 4 times 5 is 20. So I've taken care of distributing here. And then I'll also distribute on the right side of my equation. So I get 3 times 2x is 6x, and 3 times 4 is 12. So now I have an equation that looks very much like the equations in the last lesson you did, where I have variables on both sides of the equation and constants on both sides of the equation. So, in this case, what you do is you want to get all your variable terms on one side and all your constant terms on one side. So I don't really like dealing in negatives, so to me, my instinct is to subtract 4x from both sides. So I'm going to subtract 4x from both sides. Now, this is not the only first step, but to me, it's a logical first step. So when I subtract 4x from both sides, on the left side, I'm just left with 20. And on the right side, I get 2x plus 12. So I still have, I have 2x plus 12 on the right side. And again, my goal is to isolate the variable. And so I have a times 2 and a plus 12 on the side with the variable. So I'm going to undo my plus 12 first. I'm going to subtract 12 from both sides. And I get 8 equals 2x. Now I'm almost there. I need to isolate x by dividing both sides by 2. Because right now I have times 2x, and I undo times 2 by dividing by 2. That's the inverse operation. So the inverse of time multiplying by 2 is dividing by 2. So I'm going to divide both sides by 2. And I can see in this case that x is 4. So again, I want to check my solution. I don't have very much room here to write this all out. So I'm just going to kind of do little notations here and substitute in a 4 here. So 4 plus 5 is 9, and 9 times 4 is 36. So I know I get 36 on this side. And I know that 2 times 4 is 8, and 8 plus 4 is 12. And 12, so I get 12 inside the parentheses, and 12 times 3 is also 36. And since 36 equals 36, everything checks out. I'm good to go. Okay, so moving on, let's see what else we have here. Okay, so this is an inequality where I just have to distribute before I can move on here. So again, I have just one quantity that needs to be distributed to over here. So I end up with 5a minus 8 is greater than or equal to 4a minus 12, because 4 times a is 4a and 4 times 3 is 12. So now I have some constant terms and some variable terms on both sides of my equation. I want to get my variables on one side and my constants on the other side. So I think I will subtract 4a from both sides. I often make mistakes if I leave subtraction in my problems, so I like to turn all my subtraction into add the opposite, just so I can avoid any errors here. So now I can see that I'm going to subtract 4a from both sides. I'm choosing to subtract 4a from both sides instead of subtracting 5a because I won't end up with a negative a if I do it this way. So when I do this, I end up with a plus negative 8 on the left is greater than or equal to negative 12 on the right. Okay, so I'm almost there. I just need to, I have a plus negative 8, and I need to undo plus negative 8. So what's the inverse of adding negative 8? Well, it's subtracting negative 8. So I'm going to subtract negative 8 from both sides. And we know that subtracting negative 8 is the same as adding 8. And so I get a is greater than or equal to negative 4. So again, when we have an inequality, we graph the solution. So I'm kind of out of room at the bottom here because my menu's in the way. So I'm going to graph a little graph here. I'm going to plop down -4. I have a greater than or equal to, so I'm going to use a closed circle. And I'm looking for all numbers greater than or equal to -4. So there is the solution to my inequality. So again, you're going to want to choose a number in that set and check it out. So I like to do nice easy ones. I'm going to go with 0 because 0 is greater than or equal to -4. Substitute it back in here. So if I substitute in 0, I get 5 times 0 is 0, and 0 minus 8 is -8 on the left. And if I substitute in 0 here, I get 0 minus 3 is -3. And -3 times 4 is -12. And that works out because -8 is greater than or equal to -12. So that one worked. And, okay, let's try another one here. So every so often you're going to get a solution that throws you for a loop. So there's a couple of unique solutions. Sometimes you'll get a solution where you get a number equals itself. So 20 equals 20 or 10 equals 10 or 5 equals 5. Whenever that happens, the solution to that equation would be all possible numbers. So anything you substitute into that equation would be a solution. So any number is a solution. That would be called an identity. So all numbers work. So whenever you get a solution that looks like this, all numbers are a solution. Whenever you get two numbers that are not equal to each other when you get to the end of a equation, so two numbers that are not equal, that would be a null set, and that equation can never be true. There are no solutions for it. So you can either put this like null symbol or just say no solutions or no possible solutions. So we'll do a couple like that now, one of each. So here's one where we need to distribute the 3 first. So when I distribute the 3, I get 3y minus 15 plus 25 equals 3y plus 10. So before moving on here, I want to combine these two. So I get 3y plus 10 equals 3y plus 10. So you can see already that the two sides are equal. So if I subtract a 3y from both sides, I literally end up with 10 equals 10. So whenever something like that happens, that is called an identity, and all numbers work. So all numbers are a solution. Okay, so those are unique solutions that happen every so often. And then here's an example of a null set where there are no possible solutions. So again, you're going to want to distribute first. And I get -5s minus 14 equals 4s plus 6 minus 9s. And it's no secret to anyone that I do not like working in all this subtraction. So I will turn things into add the opposite. I'll combine these like terms over here. So I end up with -5s plus -14 equals 4s, and -9s give me another -5s plus 6. And so I'll go ahead and subtract a -5s from both sides, which is the same as adding 5s to both sides. And over here I get -14, and over here I get 6. And so obviously those two numbers are not equal to each other, and this is just not possible. So there are no possible solutions to this equation. This one would be a null set. So hopefully these examples have helped you out, and you're able to work through some of these on your own. Have a great night. We'll see you in class. Bye-bye.
Made with Doodlecast Pro.